Hello and welcome back to our channel. Today we'll be doing question 10 from the 2010 Step 2. This is a question about logarithms and collisions. Let's get started. Part 1. In an experiment, a particle A of mass m is at rest on a smooth horizontal table. A particle B of mass bm, where b is greater than 1, is projected along the table directly towards A with speed u. The collision is perfectly elastic. Find an expression for the speed of A after the collision in terms of B and U, and show that, irrespective of the relative masses of the particles, A cannot be made to move at twice the initial speed of B. Part 2. In a second experiment, a particle B1 is projected along the table directly towards A with speed U. This time, particles B2, B3 all the way to Bn are at rest in order on the line between B1 and A. The mass of Bi, where I is 1, 2, 3 all the way to n, is lambda to the n plus 1 minus I of m, where lambda is greater than 1. All collisions are perfectly elastic. Show that, by choosing n sufficiently large, there is no upper limit on the speed at which A can be made to move. In the case lambda equals 4, determine the least value of n for which A moves at more than 20 u. You may use the approximation log 10 of 2 equals 0.30103. Pause the video to have a think, and once you're ready, restart to see if you're right. Let's get started. In the diagram, B starts moving at speed u. After the collision, B moves at speed vb, and A moves at speed va. By the law of conservation of momentum, bmu equals bmvb plus mva. And by the law of restitution, u equals va minus vb. Solving these two equations simultaneously, we have va equals 2bu over b plus 1, and vb equals b minus 1 all multiplied by u all over b plus 1. We therefore have va equals 2 over 1 plus 1 over b, all multiplied by u, which we wish to tend towards 2u. This only happens when b tends towards infinity, and so va is less than 2u. Let's move on to part 2. Here we can see that u equals u1, u2 equals v2, all the way to un equals vn. After the collision, particle B1 moves with V1, particle B2 moves with speed V2, all the way to particle A, which moves with speed V. From part 1, we have V2 equals U2 equals 2 lambda over lambda plus 1, all multiplied by U. We also have V3 equals 2 lambda over lambda plus 1 of U2, which is therefore equal to 2 lambda over lambda plus 1 all squared multiplied by U, etc. This continues all the way to v equals 2 lambda over lambda plus 1 all to the power of n multiplied by u. Since 2 lambda over lambda plus 1 is greater than 1, v can be made as large as needed. This is because lambda is greater than 1. If lambda equals 4, then we have v equals 8 over 5 all to the n multiplied by u must be greater than 20u. This gives us n log 8 over 5 must be greater than log 20. Log 8 over 5 equals log 8 minus log 5 equals 3 log 2 minus log 10 minus log 2, all in brackets. This is equivalent to 0.90309 minus, open bracket, 1 minus 0.30103, close bracket, which is equivalent to 0.20412. We also have log 20 equals log 10 plus log 2, which is 1 plus 0.30103, which is 1.30103. N must therefore be greater than 1.30103 over 0.20412, and therefore n is greater than 7 for all integer n. And that's our answer. If you liked our video, please like and subscribe, and we'll see you next time for some more math problems. Thanks for watching, and goodbye.